So that's it for the different strategies. There's resource exhaustion, and there's hacking into systems. Now we'll look at denial of service on a different axis, and now we'll classify attacks in a different way. So now instead of thinking about how the attack is executed, we'll think about where the attack is executed. So it can either be executed at the application level, and you can think about layer 7 in the network stack, or it happens at the network level, and you can think of that as layers 4 and below on the networking stack. So now we're thinking more about where the attacker is aiming at and not what they're actually doing to take your system down. So we'll start with application level, and then we'll move our way down to network level attacks. So application level attacks, they don't have to do with the network at all. We're not attacking the network and sending and receiving packets over the internet. We're attacking the application itself, the program that's running on your computer or your server that's offering a service to other people. So we're not worrying about the network. We're just worrying about the code that's running on your computer or your service. And these attacks are sometimes specialized to the application because it depends on what code you're running. But a common theme in all of these attacks is something called asymmetry. In other words, we don't want the attacker to have to do a lot of work, and yet the attacker can cause massive damage and exhaust tons of resources on the victim server. That's called asymmetry. The attacker doesn't have to do a lot of work, and yet they have consumed tons of resources on the victim server. So an analogy for asymmetry might be something like if, as an instructor, I went and told everyone, OK, your homework is to go to the dictionary and copy the entire dictionary on paper. Now, I didn't have to do a lot of work. I just had to say that sentence out loud. But now all of the poor students have to go and open the dictionary and copy things, and you're all consuming massive amounts of resources. That's an example of asymmetry. The attacker, which I guess is me, didn't have to do a lot of work, but I forced you all to consume your resources. Don't copy the dictionary. That's just an analogy. So that's an example of using asymmetry to consume all of the resources. So what does it actually mean to consume all the resources if you're targeting an application? What kinds of resources are limited, and how can you get the server to consume all of the resources? Here are some examples. We know that file systems are limited. Your disk doesn't have infinite space. So if somehow I could get the application to run code that looks like this, where you're just writing junk to the file system in an infinite loop, you might crash the disk because the disk is out of space. Or we know that computers run using memory. Remember, we talked about the stack layout and the heap layout when we talked about memory safety. So maybe the attacker exhausts the memory in your computer. They call malloc, and they use up all the space on the heap, and now actual services don't have any space left. Or maybe they exhaust the number of programs that can run on the computer at any given time. Your operating system may not be able to handle millions of programs all running at the same time. You could write to the disk so quickly that the disk cannot support the speed of your writes and your reads. So if you can somehow get the program to run malicious code that looks like this, or if you can cause behavior like this that allocates enormous amounts of space or writes a bunch of dummy data to the disk, you could force the server to consume all of its resources along one of these dimensions.